Mendicativan Nakasinki. So he will share his experience about how to interpret the result of Gaussian calculations that have been generated by this code after it has completed. And we are still continuing the game of what would we do if there is no graphical user interface. How to read these plain text files and extract something useful from them.
Okay, good afternoon everyone. So during my presentation, I'm going to show you some ways to look into the text of an Gaussian output file. A file called a log file, and it has the same name as the input file, but with the .log extension, and it contains a lot of different important information in that file. So in this presentation, I'm going to explain how to extract total energy and how to calculate band gap and how to approximate ionization energy and electron affinity using that log output file. So I'm going to use an example molecule 135 hexatriene molecule, and I performed a single point energy calculation using that molecule for an already optimized structure using Hartree-Fock method. Okay, so I don't have the molecule right now, sorry about that. So first of all, how to weave or how to open a text file or an output file in Linux command line interface. We can use more command to open a text file or an output file in Linux command line interface. So we have to just type more and then the name of the output log file. So we can open the log file and we can scroll through this file using this more command. Okay, so this is the log file, and then the total energy, how to extract total energy from this log file. So the total, so this equation gives the total energy of a molecule according to Hartree-Fock theory. This part of the equation represents the electron nuclei interactions, and this part for okay. So this part represents the electron nuclei interaction, and this part for electron interaction. So to extract the total energy from this log file, we can use this SCF done keyword. So first we have to open the log file, and then we can search for this keyword SCF done. To search a keyword, we can use this backslash symbol. So we have to type backslash, then the keyword SCF done, and we can press enter. We can find out the total energy of this molecule. Okay, so there is another simple method to find out the total energy. We can use this command line, the grep command, and then this SCF done keyword and the name of the log file. So we can find out the total energy without even opening the output log file. So next I am going to explain how to calculate band gap. So the band gap is the energy difference between the highest occupied molecular orbital and the lowest unoccupied molecular orbital. So in order to find out the band gap, we should know the orbital energies of this particular molecule. So to extract the orbital energies, we can use this keyword eigenvalues. We have to just type the backslash and then the eigenvalues keyword. So then we can find out the orbital energies of this molecule. So here we have the highest occupied molecular orbital, alpha occupied. This is the highest occupied molecular orbital, and this is the lowest unoccupied molecular orbital. So we know the energy of the highest occupied and lowest unoccupied molecular orbitals. We can take the difference and calculate the band gap of this particular molecule. So then we can use the Koopmans theorem to approximate the electron affinity and ionization energy of a particular molecule. So this equation gives the total energy of a molecule, and then according to Koopmans theorem, if we neglect this electron interaction term, we can approximate the total energy of a molecule to sum of the all occupied orbital energies. So then we can define total energy of a neutral molecule by this equation. And for an anion, we have one extra electron than the neutral ion. So we have one excess electron. So this expression represents the total energy of an anion. Likewise, for an cation, we have one less electron than the neutral ion. So then to calculate ionization, the ionization energy is energy required to remove an electron from a neutral atom. So in another way, the ionization energy can be defined as the energy difference between the cation and the neutral ion. So it will be equal to the negative energy of the highest occupied molecular orbital. So here we have the orbital energies of these molecular orbitals, and then this is the highest occupied molecular orbital. Then we can approximate this ionization energy of this molecule, and the ionization energy of this molecule is equal to the negative energy of this highest occupied molecular orbital. So for electron affinity is the energy required to abstract an electron to form a negative ion. So in another way, the electron energy can be defined as the energy difference between the neutral ion and the anion. So it will be equal to the energy of the lowest occupied molecular orbital. So this is the energy of the lowest occupied molecular orbital, and we can approximate the electron affinity using this the Koopmans theorem. So that's it.